This is another equation practice video, and this one's on Hooke's law, F equals KE, or F equals KX, both the same thing. Forgot to put this unit on. Alright, so force is equal to the spring constant times extension. You might see a version where you use X instead. X just means extension as well. You can use either, it's no issue. So force is measured in newtons, spring constant K is measured in newtons per meter. Don't know why I did that. And extension is in meters. I think I was trying to highlight it. There we go. Anyway, make sure you've got those equations down. So there's two practice questions there if you want to start with those. Remember to pause, and then I'll take you through the answers to see if you're right. Okay, let's start. Okay, number one. A spring is 0.924 meters long when unstretched and has a spring constant of 115 newtons per meter. Calculate the force required to stretch the spring to a length of 1.713 meters. So relatively straightforward. Force is equal to spring constant times extension. So we need to do spring constant 115 multiplied by the extension, which is obviously the difference between the final length and the starting length. So 1.713 subtract 0.924, and that gives us 0.789 meters, 0.789 meters, and then obviously multiply by the spring constant. And that gives us a force that's equal to 90.735, we'll just say 91 newtons. Okay, let's look at number two. Obviously do number three if you wish. So number two, a spring is 1.23 meters long when unstretched and has a spring constant of 250 kilonewtons per meter. Calculate the force required to stretch the spring to a length of 128 centimeters. So there's a couple of things that we have to do here regarding conversions. So we're calculating the force again. So force is equal to spring constant times extension. The spring constant is 250 kilonewtons, so that's 250,000, so you need to times by 1,000. So you can either write the noughts, or you might be getting used to this now, but kilo times 1,000 is times 10 to the 3. You could write 250,000, completely up to you. Multiply by the extension, so this time we need to do the final length 128 centimeters, so you need to get that into meters by dividing by 100. So that's 1.28 meters minus 1.23 meters for the starting length. So that gives an extension of 0.05 meters, and then we need to multiply that by the spring constant. And that gives us a force that's equal to 12,500 newtons. We could put 12.5 kilonewtons. Either is acceptable. Alright, if you want to have a go at number three, and then I'll take through the answers. So a spring has a spring constant of 136 meganewtons per meter, and a force of 350 kilonewtons is applied to it to stretch the spring. Calculate the extension of the spring. So we calculate extension. So F equals KE. We've got a couple of unit conversions to do. First of all, let's rearrange to get extension, make E the subject. So we need to get rid of a times K. So to get rid of a times K, we need to do the opposite on the other side, which is divide by K. So then we just need to do the conversion. So the force is 350 kilonewtons, so you need to times that by 1,000, which is 350,000. I'm going to write 350 times 10 to the 3. If you've put 3 noughts, it's perfectly fine. Divided by the spring constant. Now this one's 136 meganewtons, so you need to times that by 1,000,000, 6 zeros. I'm just going to put 136 times 10 to the 6. Exact same thing. If you've not done standard form, it doesn't matter, you'll get the same answer. Put that into your calculator, and that's 0.0026 meters. Or you could have put 2.6 millimeters. Alright, let's do two more. Alright, here they are, if you want to do 4 and 5. And I'll take through the answers when you've done them. So on this one, a spring is 1,118 millimeters long when unstretched. A force of 51.5 kilonewtons is applied to the spring to stretch it to a length of 156.4 centimeters. Calculate the spring constant. So on this one, it's F equals KE. And this time we need to make K the subject, so we need to get rid of a times E. So to get rid of times E, we divide by E on the other side. So force divided by extension will give us the spring constant. Then it's just a matter of sorting out the units. So the force is 51.5 kilonewtons. So we need to times it by 1,000. I'm just going to write 51.5 times 10 to the power of 3. And we're going to divide by the extension. So we need to do 156.4 centimeters minus 1,118 millimeters. So 156.4 centimeters we need to divide by 100 to get into meters. Just do this down here. So that's 1.564. Subtract 1,118 millimeters. You need to divide that by 1,000, which is 1.118 meters. Calculate that first. That's an extension of 0.446 meters. And then put that up here. So you have 51.5 times 10 to the 3 divided by 0.446, and that gives a spring constant of 115,471 newtons per meter. Or you could have written 115 kilonewtons per meter. Okay, let's look at number 5. So a bit of a synoptic element on this one. Alright, I'll take you through it now. So this one, a mass of 250 grams is suspended from a spring and it extends 27 millimeters. Calculate the spring constant. So the equation is F equals KE, so force is spring constant times extension. And the mass is obviously providing the force. So with the 250 grams, we need to convert that into weight. And remember that weight is mass times gravitational field strength. And the mass of 250 grams we need to convert into kilograms by dividing by 1,000, which gives us 0.25 kilograms. And remember, gravitational field strength on Earth, we need to remember 9.8 newtons per kilogram. So that'll give you a weight that's equal to 2.45 newtons. Alright, so we're going to calculate the spring constant. So we've got F equals KE. We need to rearrange for it to make K the subject. So we need to divide by E on the other side. So force divided by extension will give us the spring constant. So the force, which you just calculated, 2.45, divided by the extension, 27 millimeters. So to go from millimeters into meters, you need to divide by 1,000. So that'll be 0.027. And then pop that into your calculator. And that gives us 90.8. So 90.8 newtons per meter. Hopefully that went okay, and I hope that helped. Thanks for watching, and I'll speak to you soon.